All right, let's complete our suite of calculus rules. So the third one, quotient. So this is for when you have one function divided by another function. So product yesterday when they were multiplied, here we are divided. Now I suppose theoretically you could use the product rule for any of these situations because you could always rewrite the denominator to the power of -1. So I mean that is an option. But we have a much more fun way of doing this. Oh, and there's the technical rule, yeah, fair enough. No. Square the bottom, right down the bottom, diff the top minus, right down the top, diff the bottom. So obviously, unlike the product rule, you have a first and a second because there's two things multiplied together. Quotient rule, you have a top and a bottom because you're talking about a fraction. So the first thing you do is square the bottom, which is simply, oh, well, whatever's the bottom, let's put some parentheses around it and go power of 2. Then write down the bottom. So now we're on the top of the fraction. Write down the bottom, 1 plus 2x. Diff the top, well, it's just x, so that's 1. Minus, so unlike the product rule, remember the product rule was plus, quotient rule was minus. That's probably to do with the power of -1 if you were to make it a product rule, but anyway. Write down the top, x, diff the bottom 2. Let's tidy the top up, and that's how we'll leave it. There's no simplification there. So one with say we've got a third in the bottom here. So square the bottom, well when you square a square root, that becomes power of 1. Write down the bottom, x squared minus 4.5, diff the top 2, minus, write down the top 2x, diff the bottom, but now, when we diff the bottom, anarchy. Bring down the power, lower the power, diff the inside. So let's tidy all that up. Well, we got 2x times a half times 2x. That's 2x squared, isn't it? Yeah. Now we have a common factor in the top, which also happens to match with the factor in the bottom. Not a coincidence, because that's what we've been differentiating. Factorise, take out the lowest power. The lowest power is minus a half. Well, because I'm dealing with fractions, that minus I'll also then throw to the bottom of the fraction. So power of a half will go on the bottom, eventually. So we got x squared minus 4 minus x squared. There it is. Now it's on the bottom, but I've also changed it into third form, and we end up with minus 8 on x squared minus 4 root x squared minus 4. Now, I'm going to let you in on a little secret. The reciprocal rule. You won't find it in any textbook. This is our secret. It's sort of like a special situation of the quotient rule, where the top is a constant number. Now, because the top's a constant number, when you diff the top, you're going to get 0. So this one then simply says, oh, well, it's just minus the derivative on the function squared. So if I have 1 on x squared, like, oh, well, minus the derivative on the function squared. Minus the derivative of what? Well, remember, the top's a constant. So we must be talking about the bottom. That's what we're going to be differentiating. So minus the derivative, minus, well, 2x in this case, on the function squared. Square x squared, you get x to the 4. X cancels into x to the 4, minus 2 on x cubed. Now, obviously, that was a very simple example of where it can be used. But it does save time rather than using the complete quotient rule. So something like this then, constant on top, so minus the derivative on the function squared, but because I've got to multiply by whatever the constant is. So the derivative of the bottom here would be 8x, so on the top we'll end up with minus 48x, and we just square the bottom. There's the answer, minus 48x on 4x squared plus 3 squared. So a lovely little rule, the reciprocal rule, our secret. That's all for today. So 9i.